In this module, we'll be discussing the network adapter, which is also known as the network interface controller. This component is the one responsible for the communication of a single network device, such as a PC, a laptop, or a smartphone, with other devices connected to the same network. But let's try to understand better what it actually means to have a network adapter installed on your computer. So what is the network adapter? The network adapter is also known as the network interface card or network interface controller and is a piece of hardware that connects a computer or basically any other network device to the network or directly to another device. These components allows all sorts of communication between devices on a private network or over the internet. This is typically achieved either by cabling the device one to another or by using a wireless protocol such as Wi-Fi or Bluetooth, depending on the adapter type and its generic functionalities. Network adapters, just like video adapters, can either be integrated into the motherboard or purchased separately as a USB or PCI or PCIe expansion card. The more advanced the adapter is, the higher speed and the more features it will support. Features such as IPv4 and IPv6, DMA, TCP offload, failover, logical interfaces, port aggregations, and so on. This will be discussed in much more details in the Networking Fundamentals course. Popular models, both for home and enterprise use, are usually manufactured by companies such as Intel, Realtek, Broadcom, Mellanox, QLogic, D-Link, and TP-Link, and can support speeds from 10 megabit per second up to 160 gigabit per second. To check your network adapter and its basic functionalities, press the Windows button and the letter R simultaneously, and then type ncpa.cpl, and then press Enter. Now, if you try this on your computer, you will most probably see less adapters, maybe one or two, unless you're running virtual machines and need virtual adapters to interconnect them. Let's review these adapters one by one and explain what they actually represent. Let's start with the adapter named Y-Fi. This is my active network connection at the moment. This adapter is a USB dongle directly connected to my computer, which supports dual-channel high-speed networking. Next, the adapter named Wi-Fi without dash is my native network adapter, which is a Wi-Fi adapter embedded in my motherboard. I have disabled this adapter as it supports only low-speed networking, and I'm currently using Y-Fi as my active network connection. Next, we have the adapter named Ethernet, which is also a native adapter for wired network connections, which came with my PC. It is disabled by default as no cable is plugged in, but would typically get the first priority by default. Next, we have Ethernet 2. Ethernet 2 is my virtual NP cap adapter, which is dedicated for packet capturing or sniffing, as we say. Ethernet 3 is also a virtual adapter which is used for my VPN connection. Then we have Ethernet 4, which is a virtual adapter associated with my VirtualBox hypervisor. And lastly, we have VMware VMnet 1 to 10. And these are my virtual networking interfaces used for my VMware virtual machines. And I know if you do not have some basic background with networking, you might get stuck on terms such as VPN, hypervisor, sniffing, and so on. But those terms are not part of this course and have much more to do with networking. Those topics would be covered in depth in my next course, Networking Fundamentals, as I have previously mentioned. Now, since we're talking about the network adapter, there must be some networking involved, and I can't really avoid it. So it's very important to remember that every network adapter is assigned by its manufacturer a unique identifier called a MAC address or a physical address. MAC stands for Media Access Control. This address is physically burned on the chip and consists of 6 hexadecimal digits. MAC addresses allow devices to communicate and identify each other on a data link or layer 2 network. Other important configurable parameters which can be either manually or automatically assigned to a network adapter are an IP address or a layer 3 address, a subnet mask, a default gateway, and a DNS server. Those will be covered and discussed in depth in the Networking Fundamentals course, and as I said, we can't really avoid these terms as they are extremely important in the configuration and the setup of a network adapter. Let's talk about networking standards. Network adapters may support different connectivity methods and networking standards. Here are just a few examples. Let's start with Ethernet, which is a wired networking protocol. So Ethernet connectivity can be achieved by using the Ethernet port or the LAN port or the RJ45 connector. The Ethernet standard is also known as the IEEE 802.3 standard or IEEE 802.3AE for speed starting at 10 gigabit per second. So if we look on the right again, we can see that the most important attributes are the IEEE standard, the data rate, the media type, and the maximum distance. So for normal Ethernet, which was introduced quite a while ago, we can see that the data transfer rate supported for this protocol is only 10 megabit per second, and the maximum distance is 100 meters. And we can also see more advanced versions of the Ethernet protocol, such as the gigabit Ethernet or the 10 gigabit Ethernet, which support 1 gigabit per second or 10 gigabits per second, and of course, longer distances. The next networking protocol we might want to mention, but we will definitely not encounter it very often unless you'll be working in a data center with SAN systems, is the Fibre Channel protocol, which is also a wired protocol. This is a high-speed data transfer protocol mainly used in enterprise environments to allow connectivity for SAN storage systems. So for those who don't know, SAN stands for Storage Area Network. Fibre Channel requires very unique and expensive equipment, such as host bus adapters, fibre channel switches, fibre channel cabling, SFPs, and dedicated controllers. Fibre channel typically runs on optical fiber cables within and between data centers and can support speeds of up to 128 gigabit per second. And of course, let's not forget the Wi-Fi protocol, which is the most common wireless protocol. Wi-Fi stands for wireless fidelity, is perhaps the most popular type of network connectivity methods nowadays. Wi-Fi connectivity can be achieved using an onboard card with an antenna or a pluggable USB dongle as I showed you before, and it supports speeds between 54 megabit per second and 12 gigabit per second. The most advanced standard today is the 802.11ax standard, which supports between 10 and 12 gigabits per second in dual channel mode. Another popular wireless protocol is the Bluetooth protocol. Bluetooth is a wireless technology designed for short distance communication between both fixed and mobile devices. It was standardized by the IEEE as 802.15.1, however, the standard is no longer maintained by them. Bluetooth is commonly used for IoT technologies and is supported by phones, cars, cameras, televisions, home devices, speakers, headphones, and many other devices that do not require long distance communication. Most modern wireless adapters support both Wi-Fi and Bluetooth by default. Now, if you have a look on the right, you can see the Bluetooth releases between 2004 and 2016 and their highlighted features. For example, we can see that Bluetooth version 2 had enhanced data rate as a main feature, and that Bluetooth version 4.2 had support for IPv6 for direct internet connection. That's all for today. I hope you enjoyed this session about the network adapter, and I hope to see you again in my next video. The next video will be an introduction to the longest chapter in this course, the memory module, in which we will be covering all types of system memory, storage memory, and much more. So take a deep breath and I'll see you in the next video.